A capacitor is a device capable of storing energy in a form of electric charge. Compared to a same size of battery, can store much smaller amount of energy, around 10,000 times smaller. In the capacitor, the size of the battery and the capacitor is the same, but the storage of energy will be much less, smaller than the battery, but it is useful enough for many circuit design. A capacitor is constructed out of two metal plates, number 1 and number 2. It is two metal plates. It can be aluminum, tantalum, silver, and etc. Any kind of metal plates separated by an insulating material called a dielectric. Dielectric is an insulator material. What are the insulator material? You can use the insulator material as paper, glass, ceramic, even air can be an insulator material. It is known as dielectric, which is placed in between the two metal plates. The plates are conductive and they are usually made up of metal, while the dielectric can be made out of any kind of insulate material such as paper, glass, ceramic, or anything that obstructs the flow of current. The capacitance of the capacitor depends on the area of the metal plates and the distance between the plates. If area is greater, the capacitance of the capacitor is more. And if you decrease the distance between the plates, the capacitance will increase. So the formula is A divided by D, the capacitance, and it is measured as farad. F is the unit. How capacitor works? Before you connect this capacitor to the battery, it has equal number of positive negative charges. Equal number of positive and negative charges at the both plates. So they cancel out each other. So it is known as electrically neutral. Electrically neutral. After we connect the capacitor to a battery which has 1.5 volt, the positive terminal is connected to the plate 1 and the negative terminal is connected to the plate 2. What happens here? The electrons from the plate 1 will move, will flow, and then here the battery will push the electrons to the plate 2, and here the electrons from the plate 1 is accumulating on the plate 2. So here it gains electrons, here it loses electrons, the plate number 2 gains electrons. After a certain time, the battery unable to push the electrons up. It is because here enough number of negative charges are accumulated on the plate 2, so which will create force of repulsion. So the battery does not have enough energy to push the electrons which can overcome the force of repulsion in the plate 2. So here the electrons stop, move from the plate 1 to 2, which means the capacitor is fully charged and it will get the voltage of 1.5 volt equal to the battery voltage. Now the capacitor is fully charged. The plate number 2 will become a negatively charged plate, net negatively charged plate, and the plate number 1 becomes positively charged plate. We have to say net positive and here is net negatively charged plate. So here is number 1, here is number 2. Now there will be a strong force of attraction and the electrical field lines are formed strongly and it is flowing from positive to negative and it holds. Now the capacitor holds charges or it holds energy. Now the capacitor is fully charged. Now if we shorten the two ends of the capacitor through a load LED, current will start flowing through the load. The accumulated electrons from the plate number 2 start moving to the plate number 1 until both plates become back again electrically neutral. Now this negatively charged particle will flow through the load. Here we have taken the lead as a load and it is passing through the load. So the lead lights and it will go and neutralize the charge and still we have electrons. So it will flow through the load and it will neutralize and finally the both plates will be neutralized. Then the charge inside the capacitor is fully neutral. There won't be any stored charge and no longer holds energy. Charging and discharging a capacitor from a power source. Here is a power source, it's a battery, and we have another device, capacitor, and we have another device here, resistor, and here we have two-way switch. Now here is number 1, switch number 1, and here is number 2 switch. Once this switch is connected to number 1, this part of circuit is activated. The secondary circuit contains a bulb which is not activated, so it is incompleted for the bulb, so the bulb will not light. So the two-way switch is connected to number 1, so the circuit number 1 is activated. Here initially you can see the maximum value of current in ammeter. Here is an ammeter, you can see maximum value of current and you can find initially the voltmeter which is connected across the capacitor. It will show you the reading 0 volt and the current in the ammeter is maximum at the beginning. As the capacitor is being charged slowly, it increases. It is controlled by, the time is completely controlled by the resistor. If you attach a lower resistor, it will take a shorter time to charge the capacitor. If you use the higher resistor, it will take a longer time to charge the capacitor, so it will regulate the time for charging the capacitor. Once the capacitor is fully charged, you can see ammeter shows 0 reading and the voltmeter shows the maximum reading which is equal to the voltage across a battery. If the battery voltage is 1.5, here the voltage across the capacitor will be 1.5 volt, which means the capacitor is completely charged. Now you can switch the to the second edge. You can release from number 1 and attach it, connect it to number 2. Now what happens? The second circuit is activated. Here the voltage, the battery is not in the part of the second circuit. In the second circuit there is a capacitor, a resistor and a bulb. Now what happens? Initially current in the circuit is maximum because the capacitor has full voltage 1.5 volt, so it has maximum amount of energy, so it supplies more energy at the beginning, and it is discharging. As it is discharging, the energy level decreases. As the energy level decreases, it pushes the electron slowly, so the rate of flow decreases, so the current decreases. Finally, when the capacitor is completely zero, if it does not have any voltage or any charge or any energy, then the flow of electron stops, the current stops, and the ammeter, if you connect an ammeter here, it will show zero reading. It will show 0 ampere. At the beginning it was maximum, at the end it will become 0. So now we are going to draw a graph during charging and discharging. Voltage charge graph. Voltage in the y-axis, charge in the x-axis. You can see here initially there is no voltage across the capacitor because there is no charge. Initially it is neutrally charged. The metal plates are electrically neutral, so it does not have any charge, so there is no energy, so there is no voltage, 0. Initially it is 0. As electrons, they are accumulated on the charge, and one plate and another plate, it loses electrons, so it build up charges in the capacitor. Slowly the charge level increases, energy level increases, voltage increases. Once the voltage across the capacitor is 1.5, as same as like the battery voltage, and then it stops charging and it stops increasing voltage, and it reaches the maximum level of 1.5 volt. Now it is charged completely, the capacitor is charged completely. Now you remove the battery. Now the capacitor is connected to the lead. Now it is discharging. During discharge, if you check the voltmeter reading at the beginning, it will have the full voltage here, 1.5 volt initial. As the energy level is decreasing, the voltage decreases because the energy is being transferred to the lead in the form of light energy. Energy level decreases, so voltage across the capacitor decreases from 1.5 volt to 0 volt. Once the voltage across the capacitor becomes 0 volt, and it is completely discharged. This is the graph for the capacitor voltage charge graph. What if we draw the graph for the current and charge? Here is current and charge. Initially, the battery supplies the full energy to the circuit. So there will be the maximum current because the battery has a full energy source. It supplies the full energy, so the rate of flow of charge will be higher. So initially the current in the circuit is high, As the capacitor is being charged, the flow of charges decreases, so the current decreases to zero. It is just opposite. Here voltage charge, here current charge. It is for the charging the capacitor graph. Okay, what if we draw discharge graph for current and charge? I and Q. I is a current and Q is a charge. During discharge, initially capacitor has the higher voltage, so it can push the charge at the high rate. So the initially the current value of current is higher because it has the full voltage. The capacitor has full voltage of 1.5 volt, so the current value will be higher. As the capacitor releases its energy, voltage is dropping, energy is dropping, voltage is dropped, so the rate of flow decreases, so the current value decreases. Once the capacitor loses its energy, it loses its voltage, and the current, there won't be any current, it becomes 0 ampere again, which means the capacitor is completely discharged. Here is a question. Example: a battery contains 9 volt connected to a switch, capacitor, ammeter, and 1 kilo ohm resistor in series. Find ammeter reading. So I want to find ammeter reading, so I use Ohm's law. V is equal IR. I is equal V over R. The voltage in the circuit is 9 volt and the resistor 1 kilo ohm. 1 kilo ohm is converted to ohm multiplied by 1000. So 9 divided by 1000 will be 9 times 10 to the power minus 3. The unit of current is ampere. It is the reading in the ammeter. Question in the same circuit: what is the charge stored on the capacitor when the potential difference across the resistor is 3 volt? Now here is a voltmeter which reads 3 volt. So there are two devices here. One is a resistor, another is capacitor, and the total voltage is 9 volt. Here is the total voltage, and the resistor takes some voltage plus the capacitor takes the remaining voltage. Total voltage is 9 volt. Resistor is taking 3 volt plus the capacitor X. So the capacitor voltage is here now 6 volt because X is equal to 9 minus 3, 6 volts. First we have to find out the voltage is taken by the capacitor. Now we are going to find what is the charge stored on the capacitor. We have a formula. Charge stored is equal to capacitance of the capacitor and voltage across the capacitor. The capacitance 12 microfarad, which can be converted like this. Capacitance 12 micro is 10 to the power minus 6. You can substitute this value here, and the voltage across the capacitor we found 6 volt. If you multiply 7.2 times 10 to the power minus 5, the unit of charge is coulomb. The another question in the same circuit: give two effects produced by increasing the value of the resistor. Here we can increase the value 0.5, 1, 1.5, 2 kilo ohms. We can use any values. So how does it affect the increasing the value of it? What is the effect? The first effect, answer: capacitor will take longer time. It takes longer time to charge. And second one, initial current will be lower. Initial current will be lower. So these are all the two effects to increase or decrease the value of the resistor. It will affect one, the time to charge the capacitor. Another, you can regulate the initial current.